effects you expect to show up in this approximation? I mean, are you going to, is it somehow the back reaction of all these waves on the expansion rate of the universe?
I'll expect some back reaction effects, yes, and the effect that Key forgot, considering it as an individual effect, whether that's robust to the inclusion of all the other effects, whether its effect is suppressed or enhanced by including these various other terms. There's also an effect that follows from the time standard. The cosmic time that's used in these procedures cannot be defined more accurately than about 1 part in 10 to the 10, according to this setup. So there'll be some kind of, you need to redefine the time standard a small amount as well. So those are the known effects so far, but nobody has yet studied two of these things being put into the system as perturbations at the same time, so one doesn't know whether they will affect each other, especially the higher order in perturbation theory. You might expect that linearly they'll still all live together, but once you consider the second order, it's not clear whether any of those will substantially change.
Concerning your notion about emerging time, does it guarantee automatically the causality principle? I mean, the use of the emerging time, as you have shown this. Does it mean that causality is guaranteed automatically, just from the definition of it, or not? Or it meets some kind of violation of causality?
It's not necessarily completely clear because there are different sorts of causality. If you mean, for instance, quantum field theoretic microcausality,
yes, exactly.
Then it's less clear by that stage whether it would guarantee that. I mean, I know no indications against it, but as far as I know, it's not being detailedly studied within that sort of system.
If we're talking about derivations on the order of 10 to the minus 5, and these are basically classical laws. I mean, can we formulate it entirely in classical terms? Suppose you have this noise derivations, right? These are essentially sound waves, and then you say, okay, let me calculate the energy density and pressure, energy momentum tensor associated with these sound waves, and plug it back into the Friedman equation. Is that what you're going to get?
And that's not in fact what's going on here. What's going on here is a model of the pre-inflationary phase, where one of the possibilities for where the fluctuations we see today originated from. So this is a model pre-inflation, then inflation magnifies those fluctuations, and then one possibility is that the fluctuations as a galaxies today were quantum fluctuations before inflation expanded them a great deal. So it's a model prior to inflation. So it's not a model of the universe today, although it becomes a model of the universe today at large time limits and assuming that inflation occurs as part of the development of such a universe.
And then we're talking about 10 to the minus 5. What is 10 to the minus 5?
It's the ratio of the Hubble to the Planck mass.